Good afternoon, everybody. My name is Marcelo Ang. I'm a professor in Mechanical Engineering Department in the National University of Singapore, also working in robotics. We have an advanced robotics center. So I'm happy to share with you robotics and intelligent systems and its role in the world today and what we call i4.0. So let's look at technology in general. Industry 0.0 means use our bare hands, right? Pick up things. But humanity is very intelligent. Can we take advantage of mechanical advantage? Pulleys, levers. Like when you're doing seesaw, you want to carry a heavy object on one side, you go on the other side, you go further away, you can amplify the force, right? So that's great. And the invention of the wheel to move things, right? That's Industry 0.0. Then came the invention of water power. We have water flowing. Can we use the water flowing to transfer energy? And that works, right? But then the problem is if you don't have a dam near you, no river beside you, so too bad, you're far. We cannot transmit power. Then came the invention of electricity, which means you can have power even there's no lake beside you, there's no steam power beside, there's no geothermal energy source, and we can transfer it. Then came the birth of computers. Now this is coming to just before I was born, right, in the 1950s, late 50s. And there's IT, then that gave birth to robotics. Now robotics is structured environments like a factory. It's working very well, but it doesn't work so well in everyday life. That's why you don't see robots in our homes, like unstructured environments. Another thing is here in the factory, there is human separation, while at home or everyday life out of the factory, it's dynamic environment, and there is human living together with the machines, right? And I think the future is really bringing to Industry 4.0, where we have the smart factory. Instead of automated or robotics automation, we now move to autonomous robots. Robots that can work, right, in unstructured environment, in dynamic human environments, right? Now, let me give you an important difference. Another important perspective of this, in robotic automation, it's like me walking with my eyes closed. I know I can walk because I can feel my joints. I don't need my eyes. If the factory is structured, right, conveyors, workpieces are where they're supposed to be, that's good enough. But if somebody suddenly walks in front of me, I will hit that person, right? Because I only use internal sensing. So what's needed is external sensing. Now, external sensing means eyes. I can still walk with my eyes open, I can walk better. And I can detect environments better, and I can plan actions better. So to bring the robot out of the factory to everyday life, or intelligent machines to everyday life, we need to have external sensing and more higher forms of intelligence. So what are all these components? And this is what we're doing research on, and at the same time, we want to keep education up to date. So we teach fundamentals of sensing, action, and planning, but link it also to the state of the art. So this is the factory before, up to today. In the 30 years ago, where the human is outside the cage, and when the human goes in, the robot shuts down because of safety. But now we are at a moment of great opportunities. We are at a tipping point where you have the primitive form of Iron Man, hybrid assist limb, a wearable robot. One day, perhaps I can wear this, then I don't get so tired when I do rock climbing or mountain climbing. Or the robot inside the human body, left arm, right arm, operating on a soft organ. The doctor is still operating, like playing a game, holding a joystick, left joystick, right joystick, corresponding to these two, and cutting tissue. Minimally invasive, 3 holes, left arm, right arm, another hole in the center, right, for the camera. Robot inside the body. You are inside the robotic car. The robot vacuum cleaner inside your home, and you're interacting with the robot. So what is this? All these applications, commonality, is the human-centered nature. And that means the robots cannot be like this alone. It must work closely with humans. Robot inside the human inside the robot, and human wearing the robot or interacting with the robot, right? Perhaps one day, you all carry your handphones. One day, you will all have your own robotic handphones. Yeah, it's a robot following you around, carrying your heavy luggage, your grocery bags as you go through everyday life. So how the research is all about, or technology is all about, moving from here to here, where we want to move from these two into unstructured environments where there's human-robot interaction, typically in our homes, in our hospital ward, shopping mall, grocery aisles, everywhere else, even schools, right? And how do we move from factories designed for robots to intelligent robots adapting to spaces designed for humans? I don't want to compromise how I live because of technology. Technology must adapt, right, to existing environments which are built for humans. So that is the challenge. Now, let me talk about intelligence. I talk about me walking with my eyes closed. That's this, internal sensing. I only feel my joints. I don't need to open my eyes to know I'm standing up or sitting down or raising my right arm because I feel my internal joints. But if I'm doing that, if I open my eyes, that's high-level control, I can do better job, right? I can walk better. I won't collide with people because I can see the environment. And you can also have even higher level, is a hierarchy where you do strategic planning, right? Higher level decision making. And normally as you go down here, this is faster control, medium level, and this is lower control, and it becomes asynchronous. Now what is this frequency I'm talking about, right? This frequency, we're doing 4 things, an intelligent machine. First, sensing. How do I understand the environment? Number 2, planning. Planning what to do with that understanding. Number 3, executing the plan. And number 4, learning from these 3. That's why there's a loop. Learning to execute better. Maybe it didn't work so well, not because I sensed wrongly, not because I planned wrongly, but I didn't execute it perfectly, for example. Or plan better, etc. For example, there's a hole here. A self-driving vehicle sees that. I don't know what that is. Is that a water puddle or a hole in the road? So the only way is to guess, and you pass through it, you hear a thump, then you know it's a hole, so next time you can plan better, right? So we have to always do this. These 4 things are happening here, here all the time, but at different frequencies, right? How often do you do this, right? For a self-driving vehicle, how often do you see the environment and react? If you don't see it often enough, then that's too bad, right? Because there might be some things go in front of you, you don't see it because you don't do it fast enough, then that's unsafe, right? So some things you have to do very fast, something you don't need to do very fast. An example of the highest level one is they want to go from NUS to Changi Airport, you plan a path, right? What do you take? You take West Coast Highway, AYE, ECP, or PIE. You decide only once. You don't do that every second, right? But you may do it when there's a road diversion, when there's a block or traffic jam. So it can be asynchronous too, right? Now, when we do this 4 things, there are 2 basic approaches to intelligence, how we do it. This is traditional, model-driven. We study science to understand the world. With the understanding, we control the world the way we want to, right? Based on that understanding. That's good. We develop a mathematical equation relating input and output, right? And from that mathematical equation, if I have a desired output, I can compute the desired input. But that's very hard because, for example, to walk, model-driven approach for walking means I need to know the mass properties of my body, my center of gravity, the weight of my limbs, each part of my body, and all the fluids going in, and use Newton's law. Oh, that will not work. But does that mean we cannot walk? We're all walking without learning Newton's law, right? Why? Because once upon a time, we walk and fell. We sense, we learn, we try. Then we try again until we get perfect. So we go in those loops. We're doing what we call data-driven learning. In other words, we're learning from experience. Somehow the brain is an interesting piece of machine that can learn from experience. How do we learn from? We don't develop mathematical models, but we don't develop scientific models, but there are mathematical models that are based on what we call today deep learning neural networks, right? So of course the best is to have both, right? If we have a model, we use it, but we know it's inaccurate. We use data-driven to improve the model. Why ignore what we know, right? right? So the challenge today to achieve this 1, 2, 3, 4, especially the learning, is to study these two approaches. Now, these basic technologies are not only for robotics, for intelligent machines. And when we study in any program, including myself, I continue to learn here while I'm researching. These are the aspects that you need to learn. And these are what today I call modern AI or machine learning. So again, in realizing that, you typically have different computers, a low-level computer, computer 1, computer 2, and computer 3, etc. And if you want even higher-level strategic decision-making, you can put everything in the cloud. That's a robot, a machine, right? Now, if you have many computers together, that means they must be connected, right? So communication is very important. That's why Industry 4.0, or I would call it Internet of Things, because Industry 4.0 is only in the factory. We want to bring what's outside the factory into everyday life, what's inside the factory, everyday life. So here are some examples of the vehicles we have, for example, that we work on. This is a public bus. Hopefully, maybe in next year, early next year, we'll have autonomous public buses. Singapore already announced in the 3 districts, Tengah, Punggol, and Jurong, right? And this is that project. And we have also a car and some vehicles for non-road environments, pedestrian environments, giving people mobility. So this is our concept of mobility on demand, right? You book it using Grab. You're in university town. You want to get to Kentridge Station, but you're lazy. You want to walk. You want to ride a vehicle. So this vehicle, DJ, stands for Damien J. All our vehicles named after the my first student to work on it. He books. DJ comes. You enter the PIN. I'm the one who booked it. Then it will go to Kentridge Station, finally, but not quite, because this is not allowed on the roads. This is only allowed in pedestrian environment, non-road environment. This is what the sensor sees, how much far ahead. And you can see the little dots, that are the obstacles running. Fast forward 5 seconds. With the technology, I can do this. Okay, that goes inside the lecture theater, inside University Town, because we don't use GPS, right? Because as I said, no, humans can navigate without GPS. Huh? Although today, I know some of us cannot drive without a navigator, right? Yeah, but I grew up in the Philippines. I never read a map before. How we learn directions is just go straight, look for this, turn right, turn left, verbally. Vehicle 1, then Scott is waiting. Shared computer-operated Stanford. Also Scott. Tawit enters, keys in his PIN to make sure I'm the one who booked it. And this will go to Kentridge Station. And the other vehicle will now go serve another user, potential user. So that's what we mean by multi-class. You can see the interface is similar. And it goes, right? So perhaps in the future, you have scheduled services, buses. We have smaller cars or even scooters, giving everybody mobility. That all relies on a fleet management system where communications is very important, where each of them is intelligent, right? But collectively, it's intelligent, the whole fleet management, to give you the smallest waiting time, so you arrive in your destination within plus or minus 5 minutes, right? Okay, so I look at the robot. They are intelligent. They have local intelligence, what people call edge computing. It has its own intelligence, right? But you can also have, remember the computer 1, computer 2, computer 3 in the cloud? You can have some intelligence in the cloud. For example, navigation, right? You don't need to put it on the robot itself. You can always ask Google, right? As a matter of fact, many of our navigators won't work if we don't have 4G or data connection, right? Right? So we can also have cloud gateways, right? And the advantage of the cloud is that is the bigger brain. It's separated from the body. That's the machine, many machines connected with a cloud intelligence. The whole environment can also be intelligent. For example, intelligent light, intelligent air conditioning system. For example, there's nobody there. Why should that area be cold? It should be only cold where there are people, for example, right? For example. With intelligence, remember the 4 things: sensing the environment, 2, planning what to do, 3, executing the plan, and 4, learning from it. For example, in the hotel, right? One project we had, it never got completed, but it's a very interesting problem definition from Grand Hyatt in Singapore. Is interested to measure comfort level of the people inside the room and to regulate air conditioning. Now you begin to think, when you do that sensing, how do you sense whether people are comfortable or not? Right? I don't have much time, but if we have a class, if you take my class, we can talk about it. It's very interesting. It's really to see, to give you a clue, to see how much you turn in your bed, right? Okay, and let me stop there. Okay, and all of this rely on communications because you have distributed. So that gives rise to smart environments or Industry 4.0. I would call it Internet of Things. Everything is connected, right? And this is part of an area called DARS, Distributed Autonomous Robotic Systems, where you have individual intelligence, you have environment intelligence, but because of the interaction to communication, you have synergy. You can get 1 + 1 is greater than 2, right? And you can have self-organization and robustness to component failures, and all of these capabilities. Give you an example. Playing basketball. I used to play a lot when I was younger, once upon a time, right? And how do you play? Let's say there are 5 people who knows the game basketball, but they don't know each other. Then suddenly they're forced to play immediately. Whistle blows, play game. Do you think they can play? Of course they can play. But as they're playing, after the first minute, you know who is the one who likes to shoot the ball, but the ball never hits the basket. So next time you won't pass to him anymore, right? Right? So you self-organize. Who's the one who's good in doing a rebound, for example? So that's self-organization and task specialization. But this will change. That's why there's always learning, right? Now, if there is a coach, will that be better? Of course that will be better. That's a hybrid, right? You have cloud. The coach will be the cloud giving instructions, but asynchronously, not all the time. Time out, then you go. So that's what we want to build in a connected world, in Internet of Things, to have a collective intelligence, to be a smart city, smart environment. So I view this cloud. We have humans working with robots. Each of them have intelligence, and all around the environment also have intelligence. So they all work together, right? And the question is, how do you have 1 + 1 greater than 2, right? So in all our courses that I'm involved in, and everybody who talks about intelligent system, you start with local intelligence, then you begin to expand it, right? Where the brain is not connected to the robot itself, right? Now, everybody's talking about 5G. I think Singapore is a bit late, but better late than never. But with 5G, it brings up much more possibilities. Why? Because if communication is very fast, what it means is the brain need not be in the robot itself. Half of my brain can be out there, yeah, because I can communicate with it, because it's fast. But if it's slow, it cannot, because you need to react fast. Remember 1, 2, 3, 4? You sense, then you act fast. But if you have to wait 1 minute before action, it's too late. You're dead already, right? So let me close with this short video of our attempt for human-robot collaborative system. This is a work of one of my former students who did a master's project on this. This should be playing. One day I should be able to play. Oh, yes. That's the latency that we cannot afford, right? Imagine if by that time somebody already fell and died already, it was too late, right? The camera sees the hand. When you open the hand, you know I want something. And it detects the hand, right? And let's say later it will understand some simple dialogue. It's a bottle, box, right? And if you say bottle, it will pick up the bottle. And these are some of the data learning features, machine learning features we use. It's so hard to teach an object what a bottle is. Can you imagine doing that using scientific models of a bottle, right? The only way to tell them it's a bottle is show this is a bottle, this is a bottle. It's like recognizing human beings. How do you know somebody is male, somebody is female? Just, you don't describe, right? You get in trouble if you describe people like that. You just show people. Bottle, yeah, give me the bottle, something like that. Okay, so let me end now. And this is, you can take it, this is a QR code to see all these videos. Yeah? It's informal, this is my personal computer in my office, right? So you can just show all our work. Now, I will leave you with always thinking about these 4 things as you go through everyday life. How to sense what's going on, plan, execute, and learn from it. And see when we do things manually, how we can use technology to improve it so we live happier lives. Thank you very much.
Thank you.
We don't need to sanitize this.
Okay. Yeah, thanks, Prof. Very informative and vivid presentation. Yeah, I got learned a lot about the robots. In Prof's presentation, actually, we can see that it mentioned about environmental intelligence and the cloud many times. So how those robots are linked together? We need the infrastructure. So nowadays, 5G becomes the main topic for it's advanced infrastructure for connections. Here, I'm going to talk about 5G, share some vision about 5G system. I'm Jianwen, coming from the electrical and computer engineering of NUS. So today, I'm going to talk about 3 things. First one is the main feature of 5G. And then I'm going to talk about what's the possible applications in the future. And then I'm talking about some readiness for the 5G in terms of the training of the workforce. So 5G is the short name for the 5th generation of broadband wireless digital networks. So as you can see here, actually we are evolving from 5G all the way to 1G all the way to 5G in less than 30 years, actually. And I like this picture because it shows that from 1G to 4G all the way, the main device connecting the network actually is the mobile phone. Whilst you look at 5G, it's not a mobile phone anymore. Of course, mobile phone is one of them. All right. So 5G now is talking about connection to more devices, your car, your robots, the sensor at home, and even more than that. Because 5G also talking about connecting the computation capabilities in the networks, how to allocate those computation capabilities as well. So it's more than just a communication networks. Whilst in 1G to 4G, messaging communication is the main task. So that's why 5G is quite unique in this environment. Okay. So what's the main feature enable those 5G here? Mainly they have 3 features quite attracting to us. First one is high rate. So you can see it can go up to 20 gigabits per second. What's the concept of this one? Means that you have a 2 gig hard disk, you can fill it in just 1 second. Right? And those are very important for some automation, video streaming applications. Second one is low latency here. So you can see this one actually is possible to reduce the delay within 1 millisecond. Whilst in 4G system, it's greater than 10 milliseconds. This is going to make the real-time application possible. For example, like the remote surgery and also autonomous vehicles, right? And the last one actually is one of the most important one, which is the massive connections. So it enable the connection of high density of devices. So it's 100 times of the 4G system. So this enable of the IoT and also the smart cities. Because in a smart city and IoT, we are talking about not just connecting the handphone, you're also talking about connecting the sensors, all those devices. So the key technology enable those features actually come from 2 areas. One is the new transmission technology in the physical layer, which is the main research area of department, including a few things. First is the resources we are talking about. Because we have a more spectrum to use in the 5G system. Beyond the sub-6G, we're also talking about the spectrum goes beyond 28 gigahertz. So we have abundant resources to transmit information. That's why we can transmit faster. That's why we can transmit a high amount of data here. And also you have, because the wavelengths becomes more shorter, so we can reduce our cell size. The advantage to reduce the small cells is that we can have our device, our connection in a more density ways. Then the effective transmission technology actually is talking about modulations here, which is the application of the recent research results in physical layer. We're talking about a massive MIMO and OFDM, right? And then 5G also allows a very flexible transmission here in a short time period, because in some cases in the cells, one user may need to transmit a high amount of data. So you can arrange such kind of requirements by using the beamforming scheme. Okay, so all those are actually the physical layer transmission. And also those techniques come from advantage networks. Okay, so in the network side, we have the software-defined networks. So this one actually separate the network into two planes, the user plane and the management plane, right? So the management of the whole network becomes more flexible. It also have the network slicing functions. Just imagine that if a hospital and a refinery actually connect to these networks, those two places actually have a very different requirement on networks in terms of sensor, in terms of process, in terms of the demand for the computation capabilities. Well, we can, through the network slicing, actually can provide two virtually independent networks to those two users. And also they have a network function virtualization. This one actually enable that we don't limit by the geographic locations. Okay, we can use a device from different places very conveniently. Okay, and the last one actually is also a feature of a 5G system. It's quite important in the sense that, like I mentioned just now, 5G is not just connection. It's also provide those computation capabilities needed for the device in the networks. So in this case, actually, the edge computing is important in the sense that they can reduce the latency. They can secure your data safety. All right. Yeah. So that's the 5G can provide to us. So I borrowed this one from Syntel's website. You can see that so far we have two sets of the Singapore covered by the 5G system. And also the data rate now we can achieve is 1 gigabit per second now, right? And by the 2025, actually there are two nationwide 5G systems. So it will bring more opportunities for us. So what does it mean 5G for us? Based on the three main characteristics we can see just now, actually you can see 5G system is talking about connecting various places together through this network and provide the computation capabilities for smart applications like the autonomous vehicles, robots, and all this, right? Yeah, so you can connect the sensors from home, the sensors from the hospital, from the shopping mall, from the traffic, from the company, from the farm, and etc. Some of you may say, actually, we have something connecting this already, which is the power wires, right? Yeah, power network is connected to all this place today, but only the energy flow in there. It's not information. It's not the computation capabilities. It's not something can help people to make some smart decision. So this is 5G can do for you, all right? So since it's a high rate, 5G, of course, gives us a better connection experience, all right? And also this means that we can get the response quicker. We can access our videos faster. We got a high resolution, all this, right? And also 5G enable those working and education anywhere. Because like I mentioned just now, we have three features for 5G, whereas a high rate and low latency. This actually make the working from home, study from home actually is possible. And this also triggers some applications like the 3D videos, augmented and virtual reality, and also those industry education automations here. So we can see a lot of business opportunities there. And due to those 3 years pandemic, actually you can see this becomes a real applications and needs nowadays. Yeah, that's why for 3 years, this is the first time I I speak in front of people without a mask. Yeah. And then also IoTs. Yeah, IoT is essentially just a big amount of sensors connect together and also get the computation capability to help them to make decisions on that, right? Yeah, so 5G networks is going to serve this purpose in this process. Autonomous vehicles as well is going to be one of the applications built based on 5G, right? So for autonomous vehicles like I mentioned just now, right? So in autonomous vehicles, vehicles must communicate with each other. Vehicles also need to communicate with the sensors. Vehicles also need to send the data to do some computation in the cloud. Like Prof mentioned, actually the brain is not with the robot. Same happens here. The brain may not only in a car, it can be in the cloud. So they transmit this information to the cloud. The cloud help them to do the computation and help them to make a wise decision to achieve a better travel experience and for the safety, right? Yeah. And also the high resolution broadcasting. At first look, this may not be a so interesting applications, but consider the success of TikTok. This may be a very big market as well. Yeah. So this is going to bring a better entertainment experience for people. And it seems like there's a very big consumer groups for this kind of applications. Then Industry 4.0. Industry 4.0 actually relies on the timely data and smart decisions. So 5G system actually help Industry 4.0 to optimize their manufacturing process, help them to optimize their logistics, and also help them to process the order. Yeah, so one of the things actually you can notice that they are talking about blockchain in order here, right? So talking about the 5G, as you can see from this figure, I borrowed from some magazine. You can see these two areas, automotive and cloud service, is going to be affected by 5G significantly here, right? Yeah, so cloud service actually is part of the computation capacities provided by the companies, not from ISP like the Singtel or StarHub. It can be any companies, small companies, all right? Then sales, you can see that 5G is going to affect the information and communication and manufacturing a lot. It can bring a lot of opportunities for healthcare, supply chain, and public safety, autonomous vehicles, and smart homes, smart cities. Right? So all this going to have a big changes. All right, so talking about values for 5G for the workforce, I think there are two areas. First one is that because those technology, the 5G networks is quite different compared to 4G, so we need to upgrade our networks. This is going to need a lot of skillful technicians for the deployment of such system, maintenance, and also the operation, because they're going to interface with some small companies providing the computation powers. They also need to face in the clients which need service from the 5G networks, like the hospital, steel plant, refinery, all this, right? Also, when 5G system apply, it also means that we need training our employee such that they can help the company keep in an advantage position compared with the competitor, and also helps the company to discover new opportunities given a 5G system. Yeah. Okay. I think that's all I have for this presentation. Thank you.
Yeah, thank you. I think I'm the last speaker. So it's always challenging to be the last speaker. So my topic today is on the importance of technology planning for Industry 4.0. Honestly speaking, I think technology planning is not just for Industry 4.0. It's actually meant for any R&D projects. But in response to today's theme, I think it's important because of the nature and characteristics of Industry 4.0. So while I was preparing for this presentation, I went to look for the characteristics and definition of Industry 4.0 and to try to prepare my slides to be in line with the topic today. And after reading a few articles and etc., I've concluded that it's probably more about connectivity, about integration, about smart system and AI. And I think the previous two speakers have mentioned about that. It's all about this is AI, machine learning, etc. So with that characteristics and the nature of Industry 4.0, so I would say because of that, the R&D people in the company, they might not have all the knowledge that they that are required to integrate all the systems together, all the different types of technology. I mean, you know, when we are doing a master, doing a PhD or even bachelor, we learn some technical field, but it's quite niche actually. You learn robotics, but you might not know about 5G, etc. It's a totally different field. But how do you actually integrate all this together and in order to make the system work? So in that case, you need to learn from others. And how do you learn from others? You can actually learn from others by reading through the patents, by reading through the scientific journals from people who are experts in this field. So with that, it makes this technology planning and understanding from others, people from other fields more relevant. So so learning from other people and reading patents is not just about reading individual patents and just one. Because it's a vast field. There's a lot of different type of technology. You need to learn and you need to read, but in quickly and in huge volume. So you need big data analysis. Big data analysis, what I mentioned just now, is about reading patents, reading scientific journals from other people. I know some people, and then you can produce the technology landscape, patent landscape, etc. I know some people are actually quite skeptical about this patent landscape. You can have nice pictures, you can have a helicopter view, 3,000 feet, etc. But so what? What do I learn from it? How do I get insight from it? So that's the challenging part. So the purpose of my presentation today, of course, is to tell you that how you can actually get more insight from all these big data charts, etc. But before that, I think I would like to just summarize on what are some of the decisions that you can expect to make from data crunching, from data analysis of patent information, of scientific generation information, etc. So some of the decisions that you can expect to make may involve like securing a technology roadmap, because you learn what your competitors are filing. You learn what they're doing, the filing strategy, even new startups, emerging companies, etc. So from there, you can actually plan your technology roadmap. You can also detect opportunities from your competitors. Because you know what they are filing, what they're researching in, you might want to either look a little bit more in details on what they're doing, and then to try to design around, etc. And once you know more about the technologies, you can actually identify opportunities or maybe emerging technologies, and you can assess these emerging technologies to see whether they are relevant or not. Can it be applied to your system, to your company's product, etc. With a better understanding of the overview, background of the landscape, you can actually drive allocation of funding to R&D projects. I call this data-backed decision, because sometimes, how do you decide whether this project should get more money or the other project should get more money? Is it by your gut feeling, by your general understanding of the market, etc.? So by doing some data analysis, you can actually, have some proof on which to invest in, and then knowing which the best technology to invest in, you can actually reduce the time to market. And by understanding who are the players, etc., what they're doing, you can actually benefit from dynamic innovation ecosystem. You can actually select who to partner with, collaborate with, etc. So this slide just talked about a little bit of what kind of data am I talking about. I mentioned about patent information, scientific journal information, but actually it's not only that. If you want to have a more comprehensive analysis, you need to have more, because patent data is dated. There is an 18-month gap before the patent is being published. So we are talking about 5G, robotics, etc. These are actually fast-changing technology. Patent information will not provide you the complete picture. So you need scientific journals, but more than that, you actually also need to analyze website information, etc. The reason is because a lot of startups are working in a lot of interesting technology, emerging technology, but they don't file patents, they don't have the money, and they don't publish scientific journal. They're not in the academics. So how do you know what these startups are actually inventing, etc.? They might talk about it in their websites. They might tell you on the website that they have participated in certain competition, etc., and they won a prize, etc. So you can learn more about this by reading curated websites. So this data analysis also involves that. So you can, depending on which technology you're talking about, you can also involve clinical data, can involve project and grants from governments. You can also, look at data for companies, for startups, etc., and also merger and acquisitions. But you can never get insight with just the data alone, because it's not curated, and it's just, you can't think of anything, you can't turn it into insight. How you can actually turn data into insight, there has to be a process, there has to be a system. Since I'm in the engineering department, we are all about system, right? So for data analysis, it's the same. So here I laid out a simple process of data analysis. First, you must have the data, which I've talked about in the previous slide. And then after that, we can actually leverage on characteristics of Industry 4.0, which is machine learning, for example. You can actually use machine learning to identify concepts in patent document, in scientific journals, to understand what they're talking about. You can use technology to normalize information such as the company's names, etc., because companies can have a lot of names and so on. So you do this, you curate the data, to clean up the data. Once you have a clean set of data, you'll be able to draw charts and draw insights from there. And of course, technology allows you to customize the charts. The more customizable the charts are, the better insights you'll get, because you can, if you ask a different question, you can tune the charts in such a way that it provides answer to you, and so on. So that's the general process of turning data into insights. But I must add, for the final stage and the most important stage for turning data into intelligence, there must be human connection. I think machine at this moment is still not at the stage that you can make the final decision, especially to bet on which technology to take, to spend millions of money on that. You still need to have some sense, and I mentioned there's this data that we talked about, but they are not all. They are not all. You still need some other information. So human will be able to do that. So with that, all that background, that leads me to the meat of what technology planning is. And I'm just going to go through a few points that I think is very relevant in this fast-changing technology space. The first one is about doing due diligence. There's a Chinese proverb that says knowing your competitor is the best of, it will allow you, enable you to win the battle, etc., something like that. So you need to do competitor monitoring. You want to know what the competitors are researching in, and most of the time people they will file patents in that to protect themselves, to ensure that they have the monopoly. So by looking at what patents they are filing and so on, or what people are talking about in the website, you know what they're doing. You can also identify potential competitors that you might not know, because there are so many startups and so on. So that helps a lot if you're doing this competitor monitoring. And due diligence also involve checking whether your technology has the potential to file patent. Patent gives you the monopoly to operate in the market, and if people are using your technology, you have the right to sue the other person if they are not licensing from you. I just give you a very simple example that is ongoing in this Industry 4.0 technology. Is about this company called AutoStore and Ocado. AutoStore actually is a vendor of Ocado. So it provides automated, it provides a system of arranging storage grid in the warehouse so that you can get the robotic systems to get the top items and lower it down. So AutoStore filed a few patents in this area, and Oracle used to be a customer of this company. But recently they came up with their own system and then a platform to allow their own robotic systems to get items from the top. And AutoStore filed a patent as a result in UK, in US, in Germany as well. It's still ongoing, and it's quite a high stake case. So if you don't do your due diligence, the result is that you're involved in a lawsuit. And in addition to that due diligence, what technology planning also involves is that it also involves providing you information about how to actually integrate different technologies. So over here, you can see that there's a technology landscape map, what we call. The technology landscape map is a contour map. Each dot in the diagram itself represents one patent family, and each different color represents the company having that patent. So you can see in conclusion, and using the technology of grouping different concepts together, keywords together, you can see that some technology area that are traditional to warehouse technology, I just make use of the same example, is storage structure, inventory, shelving. These are normal technology. So if you are the company that doing warehouse technology, you will know this technology. However, because we're all talking about AI, etc., there are also technologies that you can see is AI sorting system, unmanned delivery. So you might not be aware of who are the people that are providing this technology, how do they integrate into the warehouse systems. So by understanding all the patents that are filed in this area, who are the providers in this area, you can actually identify who to work with, collaborators, partners, or even potential acquisition targets as well. With this information of technology data analysis, you can also identify which technology to bet on. So here are some charts from my students in the technology intelligence class. I really like this project because they did a very, very good job in analyzing all the technologies related to a warehouse technology. So they made it very simple to categorize the technology into move, sort, move, pick, and sort. It's just simple, short and sweet, to make the whole technology simple. And then eventually they analyze the following trend of these technologies. They analyze who the players are in this technology. And then they make a decision to say that the company should invest in the sort technology because there are not too many patents filed, yet the CAGR is the highest. So there is potential that the company can actually file patents in that area to get protected and not to be sued as well. Yeah. So the last point that I want to bring across in my presentation is that with the data analysis, you can actually assist you in open innovation because, as I mentioned, you cannot do anything on your own now because of system integration. You need partners, you need collaborators. By doing data analysis, understanding who the main players, the competitive analysis, etc., you can actually identify who to work with and analyze their filing strategy, analyze who they are working with, which universities they're working with, and also you can maybe potentially identify who the new hire may be. You can identify the R&D people working in that particular project, so you can actually poach people from this data analysis. So to conclude, I would say that, data analysis, big data analysis is not new, definitely, but it is very important for Industry 4.0 because if you have a good oversight, you can make sense out of this data, you can actually accelerate and improve your technology and help you get technology to the market faster. So thank you very much.
for the screen to come up. Do you have any questions or comments? Please feel free to ask any of us. Okay. I think one challenge is the learning new things. Yeah, and the fact it's new, it's very hesitant. Am I able to learn? Do I have the necessary training? Right? And my answer to that is you should watch Star Trek. Boldly go where no man has gone before, right? You just have to step on it, right? And try it. You won't know, right? Everybody doesn't know. You don't know what you don't know, right? You have to just embark. The internet is there. There you can learn so many things, even good and bad things, right? So you just have to try. I think it's a challenge, but it's an opportunity for you to learn, right? I think I wish I was your age, yeah, when the internet was easily available. Before, to get information, I have to go to the library. If it's not available, I have to do an interlibrary loan, wait a few weeks, yeah? And some quick comments.
So I just want to add one thing, which is the new trend to working from home, studying from home. Because previously we do a project together in office, but nowadays, especially due to the pandemic, we have to work from home. So how did you manage your team as a manager? Actually, it's quite challenging. Most of the people at the very start think, okay, it's quite good. We can working from home. We don't need to travel. We can save a few hours commuting. But actually, it's not. If people realize that working from home become even more harder compared to working in office, because you have to take care of your family. At the same time, you have to work. You have to respond to your colleagues. Yeah. So I think this may be one of the challenging for managers.
Just to add on, right, I think honestly speaking, for my technical field, not really technical field, the data analysis that I'm working on, I actually learn every day from reading the patents, from reading the scientific journal. So there's actually opportunity you can venture in a new field like data analysis, pattern analysis, and without being too technical in the area. So this is actually opportunities, I would say.
Maybe, how about the audience here? Take advantage you're here. One last question, then we close. Yeah, please, good, thank you. Designed for humans, yes. Yeah. Right. Yeah, I think it's good. Quite challenging that we face and we plan for. Yes, that's right. That's very important. Very important indeed. But then I have a philosophy. It's good to talk about it. It's okay to design an office, a space, to facilitate easier use of technology, as long as it does not compromise humans. In other words, forget the technology. Without the technology, will you design the space like this? If the answer is still the same, then good, right? Because I don't want, for example, autonomous robots to help them not get lost. They put barcodes in the building, QR codes. You see this in even manufacturing, fiducials, they call them, like markers, right? Now, would you like your home to have full of barcodes? If the answer is yes, then of course, we can do that. Yeah? But today, we're working, my philosophy has been, we have to build technology so we do not rely on infrastructure changes to facilitate technology. Yeah? Because infrastructure, space is designed for human beings. Yeah, it should exist without having to, yeah, same circulation space. Should be able to. Yeah. Yeah. Yeah, that's right. Yeah, yeah. But then there may be less humans. Yeah. Okay. But in general, my answer is it shouldn't. It shouldn't. Yeah. 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 But it's a challenge. Yeah. Yeah. Okay. Thank you. Okay. No closing remarks? But maybe I should. Thank you very much. It's nice. I miss having classes like this. Yeah. Okay. Thank you and be safe. Thank you.